Okay, so this is 2-4. We're going to finish this up. We're starting with objective C. So talking about function notation. And we're going to be evaluating, so plugging in certain values here. So remember, f of x is just a fancy way of writing y. So I always say, it's like print in cursive. So y is the print, f of x is like the cursive version, a fancy way of writing y. But they mean the same thing. F of x is still your output. It's still the, vertical coordinate on your graph. We read it when you see f parentheses x as f of x. Okay, that means function of x. You're not saying, it's not an operation, so it's not f times x. The parentheses don't mean multiplication there. It's not always f. It could be g, like g of x, h of x. Those are other common letters used there. Kind of just depends on what you're describing. If it's a word problem, it could be like h of t, where you have height and time, things like that. Okay, so here, for this function, f of x equals 2 times the absolute value of x minus x squared, I want to find these values. So I'm plugging these numbers in for x. It's usually f of x, but now I'm given a specific value. So I'm going to evaluate and figure out what the number is. Okay, so you don't want to make little calculation mistakes here, so you might want to use your calculator. Now, absolute value, that's not on the scientific one, so you'll have to actually work that part out. The graphing calculator, it's under math, and if you go over to number, then it's the first choice. There's also a place, if you have a newer graphing calculator, and you hit the alpha y equals, and it gives you a little menu for fractions and radicals and absolute value. Right. Yeah, of course. So you could just do, if you have a scientific calculator, you need to actually do the absolute value. So absolute value of 3 is 3. And then type in from here. Again, you could probably calculate that in your head. You could also do it in pieces, but I just see more mistakes the more you try to do that. So just double check it with your calculator. But you should get -3. Okay, f of -2. So what is the absolute value of -2? +2, good. So you at least need to probably do that much in your head, and then you could type it in to check. But again, now you should get 0. So now I'm plugging in a variable. So I should, my answers should have variables in them. So I'm plugging in -a or opposite of a. So when I go to do that, let me write it out first and then we'll talk about it. Okay. So the absolute value of -a equals the absolute value of A. It does not just equal A. Like, you cannot just say this, because if A started out as negative, then when you did the absolute value, you would get a positive, and that wouldn't be A. Right? So it's not this. Absolute value of negative A equals absolute value of A. Okay? Negative A squared is A squared, because you're always going to have a positive. But even if A started out as negative, when you do a negative number squared, you still get a positive. So these are kind of two pieces that we need to know. So that means I can simplify this to absolute value of just A, and then minus, so negative A squared is A squared. These two negatives don't cancel to make a positive. Order of operations, you do the exponent first, which gives you positive A squared, and then your subtraction. Okay, so does everybody see how we ended up with this? Okay. Now I have an expression, so I'm going to take this f of h minus 3, and I'm plugging this whole thing in for x. So I have 2 times the absolute value of x, which is h minus 3, minus x squared. So I'm doing this whole thing squared. Absolute value is not the same as parentheses. You cannot distribute inside absolute value. Okay, so I'm just going to leave this as is. But I can multiply this out. So I'm going to go ahead and multiply this out. It's not going to really help us simplify anything, but in other problems it does. So we'll just get used to, if you see a binomial squared, go ahead and multiply it out. So either write it twice and use FOIL, or you can use the shortcut. So either write it twice and FOIL. I would do that just to the side, so then you don't mix up what you have. Or you can use the shortcut, which is a squared plus 2ab plus b squared. Okay, so again, I'm just keeping this 2 times the absolute value, h minus 3. There is a way to kind of simplify that, but it would involve using plus or minus, and it doesn't really get us anywhere, so it's okay. We'll just leave this like this. All right, but I have a minus sign here, so I know I'm going to have to subtract this entire quantity, so I'm going to keep it in parentheses so I don't forget to distribute that negative. All right, so if I use the shortcut, it's h squared. Okay, now I need 2ab. So ab is negative 3h times 2 is negative 6h. And then b squared, so you're going to, negative 3 squared is positive 9. Now distribute your negative. So if you have parentheses on these, go ahead and remove the parentheses by either distributing or multiplying out a binomial square. Okay? But if you have the absolute value, it can stay there. So minus h squared plus 6h minus 9. I'm not going to worry about rearranging the order because you have an operation inside here. So I'm just going to keep it like this. Okay, so any questions about that? Everybody see what we did? Everybody okay with us inserting it in for x? Okay? And then all I did from there was just multiply this out. Since it was a minus, I had to distribute that negative. Okay? All right. Then the other part of this chapter here, or this section, is reading graphs. So being able to interpret the graphs. Domain and range, and then picking out certain values. Okay, I noticed first of all that this graph is not connected. So for my domain and range, I'm not looking for an interval. The intervals would mean that I need every single point, even in between these points. So when you're just given single points, whether it's in a table or a graph, then you are listing out every individual point. So I think it might be kind of helpful to either make a table or write out the order of pairs here. So I'll help you out with that. So that's negative 5, 5. This is negative 4, 4. Negative 3, 3. Negative 2, 2. Negative 1, 1. 0, 0. 1, negative 1 here. And then I'm at 2, 0. This is 3, 1. This one is 4, 2. And 5, 3. Okay? So I'm given single points, so my domain and range, I have to list the single points. There's only one way to do that. So I'm going to say x equals, and I use those braces, and I list them out. So I'm listing all my x values. I wouldn't write ones that repeated if they did, but this is a function, so you shouldn't have any repeated x. You can tell by the graph, like if you draw lines, vertical lines, it only goes through each point one time. So negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. So that's what I have to list out. So it is, yeah, a little tedious. There's not really a short way to write this. You can write it in set notation, but you have to designate that they're integers and not real numbers. We haven't done that before, so it's just easier to list them out. You cannot say negative 5 to 5 or write an interval, because that would mean you're asking for like negative 4.5 and 1.5, but that's not part of your graph. So you cannot just write negative 5 to 5. All right, then range, we do the same thing. But this time we want our y coordinates. Least to greatest, so remember you're reading at bottom to top. So you have negative 1, 0, and you have 2 zeros, but that's okay, just write it once. 1, 2, 3, 4, 5. So negative 1 through 5. So negative 1, 0, 1, 3, 4, 5. It's okay for your y values to repeat on your graph. Only write them once with your domain and range. All right, we good with that? We see why we have to list those out. Okay, if the graph were connected, then I'd be writing an interval. Okay, so on C, it says find f of 2. So is 2 an x value or y value? X. You know, normally it's f of x. So 2 is an x value. So on your graph, find where x is 2. Okay, so right here. What is the y value there? 0. Good. Alright. So you might have noticed this k value at the top of your graph. That really didn't mean anything until right here. Okay, so I don't really know why they do it like this, and they don't just tell you find f of x equals 3, but they don't. So that k equals 3 is what you use here. So is 3 an x value or y value? 3 is a y value. So I'm finding x where f of x equals k, and this tells me k is 3. All right, so I want to find x when y is 3. So I go to the graph, and I have y is 3 right here, and also right here. So I have two x values where y is 3. Oh, I'm sorry, x equals negative 3 is the first one, and x equals 5. We have questions about that? No? Okay. Why is that x negative 3? So I'm looking for what's x when y is 3. So when y is 3, so here's 3 on y. I'm here. And also, so here's y is 3. So I have two different points. And x is negative 3 here and 5 here. So all we're doing is just reading and interpreting this graph. So make sure you understand what values it gives you. Is it giving you x or giving you y? And then you find the other one. So we're going to do that again, but this time our graph is connected. So I'm going to give you a minute to go ahead and try this one. Carly, what do you have for your domain? Good. So I have an interval, and it's negative 3 to 5. Both of those are included, so brackets. Good? Okay, Susan, what about your range? Okay, good. So negative 4 to 5. So, you know, range is your bottom to top, okay? Domain is left to right. These are your boundaries. So if you're going to box this in, this is what you would have your boundaries from. So your negative 3 to 5 here, and then negative 4 to 5 here. So it's your minimum to maximum. I know it's really easy to want to do the endpoints. So we want to do 1 to 5. But that wouldn't cover your whole graph. The minimum of your graph here is negative 4. The minimum is down here. Okay. Okay, Jolie, so C is f of 2, is to our x or a y. Okay, so what is the y value where f is 2? Negative 4, so right here. X is 2, that's negative 4. Good? And then I'm looking for x when f of x equals negative 3 because of that k value is negative 3. So Corey, is negative 3, what it gives me, is that an x or a y value? Okay, so what is x when y equals negative 3? Good. So here's where y equals negative 3, and that hits the graph at 2 places, where x is 1 and where x is 3. Good. Questions about that? Yes. Yes. Okay, we're going to talk about piecewise functions now. Just evaluating them, we're actually not going to be writing them or graphing them until 2.7, but we're going to go ahead and start talking about evaluating them. So basically, the only difference is that you have to choose what part of the piecewise function you want depending on your domain, so depending on your x value. So piecewise functions are 2 or more functions together. So my steps here say you check to see if your x will work in the domain of the function. Okay, so you have to choose which one, and then you evaluate only that portion of the function. So you're either going to use the top or the bottom, depending on your x value. So looking at this, f of 2. So I have to decide based on these restrictions here. Is 2, is that less than or equal to 3 or greater than 3? Yeah. So will I use the top or bottom equation? The top, because it's less than or equal to 3. So I'm going to use the top. So I'm going to use 2x minus 1. And we're going to calculate just that portion. So 2 times 2 minus 1. And that will be 3. What about f of 3? So what about when x is 3? I have less than or equal to 3 for the top and greater than 3 for the bottom. So is 3 less than or equal to 3 or greater than 3? It's less than or equal to because it's equal to. So will I use the top or the bottom? The top. Okay, f of 4. Is 4 less than or equal to 3 or greater than 3? Greater than 3, so I'll use the top or the bottom. The bottom. So, I'm now putting it into the bottom equation. So 4 squared plus 1 is 17. So that's all we're doing with piecewise functions in this section. Deciding which one to use and plugging it in, just like we plugged in with just one function. Okay, questions about that? Everybody see how to use top or bottom? How we know? Okay, it will give you these. It will give you these. Okay, we're not going to do all of these. I just want to look at, I want to look at these two for 72. So for 72, I want to do f of 2c and f of c plus 1. Okay, so I'm plugging in 2c for x. Okay, so if I do 2c squared, remember if you have an exponent outside of parentheses and you multiply inside, you can distribute it. So you have to square the 2 and the c. So you have 4c squared. And then 3 times 2c is 6c. 2 times 4c squared is 8c squared plus 6. We're multiplying out, not factoring, so don't factor something out now. Okay? We're multiplying this out. All right, now let's do f of c plus 1. Okay, order of operations, exponents first. So you cannot distribute the 2 here in front. You cannot do this until you have squared this. Okay? So it's a binomial squared. You're adding inside, so you cannot distribute the exponent. Write it twice or use the shortcut. I'm still going to have to multiply 2, so I'm going to keep that trinomial in parentheses. Okay, so square a, so it's a squared, which is c squared. And then you'll do a times b, so c times 1, which is c, times 2, 2c. And then b squared, which is 1, so 1 squared is 1. Okay? I don't have an exponent outside of this c plus 1, so I can go ahead and distribute my 3. 3c plus 3. I have to distribute the 2 to get rid of the parentheses. And then combine your like terms. So that's why we multiply this one out, because we end up having like terms that we can combine and simplify. So 2c squared plus 7c plus 5. So when you plug in variables into a function, your answer is going to have variables in it. Questions about this? Okay. All right, so we're going to interpret some more graphs, but this time based on a word problem. It's actually a little bit easier, I think, than not having the word problem. You can kind of tell your variables easier. All right, so we're talking about tides, so like in an ocean. Is this a function, a graph? Yes. And because you're given a graph, you can just say because it passes the vertical line test. So you can't use vertical line tests unless you have a graph. If you're given an equation or ordered pairs, you can make your own graph and use it, but you can't use vertical line tests without a graph. Okay, approximately what time did high tide occur? Well, I'm looking for the highest point of the tide, so I'm looking for the highest point of x or y. I'm looking for the highest point of y, so right here. And what is my x value? 9. And I need to be specific here, so it's 9 p.m. Okay. How high is the tide at 6 p.m.? So here's 6 p.m. I see where that hits my graph, which is right here. And so that height, halfway between 3 and 4, 3.5, and then what's the label? Meters. Good. What time or times will the tide be 2.5 meters? So I'm given 2.5 meters, and I want to know the time. So here and here. So 5 p.m. and 1 a.m. Questions about that? Okay, so talking about rate of change, so average rate of change for nonlinear functions. Remember, rate of change means slope. So for a linear function, your slope is constant. It never changes. That's what makes it linear. However, if it's nonlinear, then your rate of change is not constant. There are parts of the graph that are steeper than other parts, or sometimes the rate of change, the slope is positive, sometimes it's negative. So it differs. So what it gives us is that our rate of change, so this delta y over delta x, that's change in y over change in x, I can still use this slope formula. okay, to calculate what the average rate of change is between two specific points. So what I'm technically finding is the slope of the secant line through those 2 points. Okay. So I know this might be a little bit hard to see in the back. All right, the growth rate of a fetus in the mother's womb by weight in grams is modeled by the graph shown, beginning with the 25th week. So there's an endpoint here at the 25th week. So our X is our weeks, Y is the weight in grams. So pregnancies are measured in weeks. So that's why if you ask someone, oh, how far along are you? They'll tell you in weeks instead of months, because really it's measured in weeks. And so then you have your full term is 40 weeks. So it's not technically 9 months. Okay. So calculate the average rate of change, which is the slope of the secant line, beginning with the 25th week, or between the 25th week and the 29th week. So I'm wanting to know the slope of, like if I were to draw a line, so that's the secant line. I want to know what that slope is. That's what it's asking me. And then I want to discuss what it means. So I use the slope formula, and I'll go ahead and use n. I have to find another slope down here, so I'm going to call that n1. So I have 1100 minus 900 over 29 minus 25. So I get 200 over 4, which reduces to 50 over 1. Well, first of all, is that positive or negative? Positive. I could tell by my graph it was going to be positive. Jacob, why is that positive? How do I know that's positive by looking at it? Yeah, because their line is going up from left to right. Okay, I also did the calculations and it was positive. So what does this mean? So on top I have my y's, which y is what am I describing here? And for y. My y variable is weight. So it's going up 50 grams, and then the bottom is weeks. Okay. So what I can say is that between the weeks of 25 and 29, your fetus is gaining 50 grams per week. But just between that interval. So grams per week between 24 and 29 weeks. Okay? We're fine. We're going to be able to finish this. All right. Now, I want to know if it's faster between the 25th and 29th week, what I just found, or the 32nd and 36th week. Well, just by looking at the graph, which one's going to be faster, the red or the green? Green. Why? Steeper. So steeper is a word. The steepness is something that slope describes. But it wants us to compare the slope. So if I find my second slope, so I do the slope formula, y2 minus y1 over x2 minus x1. I get 250 over 1. So 250 grams per week is more than 50 grams per week. you're done now.